Right, so let's start out by taking a look at section 3.1. So last week, you guys had a problem maybe like this. The sine of 30 degrees, and you'd have to figure out what it was. The important thing here is just kind of how the problem was set up. Okay? I gave this to you. I told you the angle that I wanted you to find the sine of, right? Or cosine or tangent or whatever it was, right? And then the way we did it is from here, you drew your circle and you put 30 degrees on it. Remember the options were, put it right in the middle, closer to 0 or closer to 90. Okay, 30 is closer to 0. And we drew a triangle. And we had to memorize that in the 30, 60, 90, the short side was always a half, and the long side was root 3 over 2. Does anyone remember what letter sine was? And we have to figure that out. Yeah?
Y?
Yep, it was the y. So this is my x, because it goes left and right. This is my y, because it goes up and down. Here, my y is a half. And that's how you did the problems on the test. All right? This week, we're going to kind of switch that around. So we're going to look at inverse trig functions. Okay, what I just showed you here, this is just a regular trig function. This is inverse. The inverse is basically used to undo what I just did. Kind of takes you back. And let me go to that same problem we just did and show you what it would look like as an inverse trig problem. All right, so anytime you have something in math, there's always a way to go back. Right? If you add something, you can undo it by subtracting. If you square something, you can undo it by square rooting. Well, this is how you go back from a trig function. All right, so this was an angle. This was just a number. 1/2, it's just the number 1/2. It's not an angle 1/2, it's not degrees 1/2. It's just the number that's a y value from a coordinate, just 0.5. It's like a length. Okay. So that's last week. So this week, the problem would look something like this. The inverse sine of 1/2. Right. So you can kind of see the difference. Regular sine, inverse sine. This, right here, is just a number. So now I'm telling you the number. That's what you had to figure out last week. Right? You had to figure out the number 1/2. Now, I'm telling you the number is 1/2. What you have to figure out is what goes right there. That's the angle. Right? So now you're figuring out the angle, and last week I gave you the angle. So what do you think this one would be if you type that in, inverse sine of a half? What do you think that would give me? Yeah, it would give me 30 degrees. Right. So taking the sine of 30 and getting a half, and then taking the inverse sine of a half and getting 30, it's like taking a number and adding 2 and minusing 2. It just brings you right back to where you started. All right? So this is the kind of thing you're going to have to figure out this week. Okay, what the angle is. And once we know how to figure out what the angle is, then we can get into a problem, something like, say you got a building and you're standing 100 feet away from it, and you look up at the top of the building, and when you look at the top of the building, you're looking at an angle of, let's say, 20 degrees. Now we could figure out a couple things. We could figure out how tall the building is, right? Or we could kind of do the opposite. If they said, all right, the height of the building is 30 feet, what angle would you have to look at the top of the building? Okay, you could figure out the angle. Like if you were trying to aim something and hit a target on top of the building. All right. So we'll be able to kind of look at some stuff like that. All right, so you kind of saw me write this symbol here, like this sine -1, but I didn't really explain too much or write it down. The way you pronounce that is inverse sine. Okay, that's one way to write it, sine with a -1. There's another way to write it, and it's arc sine. It means exactly the same thing. All right. This is like a newer way to write it, sine with a -1. But if you were maybe doing something where you had a hard time writing exponents, like older things that couldn't do exponents, well, you could write this and it means the same thing, arc sine. Right. And that doesn't use an exponent. Same thing for inverse cosine. Cosine with a -1, or arc cosine. And the same thing for inverse tangent. Now, I'm only writing those three because if you look at the calculator, those are only three you have buttons for. Inverse sine, inverse cosine, inverse tangent. Doesn't mean you can't do the other ones. Secant, cosecant, and cotangent. We did those last week. Not the inverse ones, but we did the regular ones. Does anybody remember what you had to do to get the secant, the cosecant, or the cotangent? You had to take one of the other three and do what with it? Flip them, right? It's kind of the same idea here. If you want to do one of the other inverse trig functions, you've got to flip something. It's not quite the same, but we'll look at it. Now, if you start typing in a lot of different inverse trig functions, you're going to start to notice a pattern, right? Let's just type in inverse sine of 40 degrees. Oops, I'm not in degrees. So another thing that's going to be important this week is making sure you're in the right mode, radians or degrees. All right, so let's type in sine of 40 degrees, 0.64. Let's type in sine of 85. You get 0.996. Let's go sine of 89. I'm getting pretty close to what number there?
1.
1. Does anybody remember what angle gives me exactly 1? 90. If you go sine 90, now you're at 1. Now watch what happens if you go sine 91. It's almost like you went up to 1, and now you're coming back down again. Right. It's actually sine of 89 and sine of 91 are the same. Okay, so it's like symmetrical, comes back down. But 1 is the highest it ever goes. Okay. So let's take a look. Oops. So now, let me go back to my calculator. And now we know 1 is the highest that a regular trig function goes, and -1 is the lowest. Just trust me on that. It's 1 to -1. So let's try typing in numbers between 1 and -1 and do the inverse. Okay? Just look for a pattern. Let's try 1. Well, we know that. If you type inverse sine of 1, you get 90. Let's try inverse sine of 0.5. I did that one with you guys when we started. That was 30. Let's do inverse sine of 0. Get 0. Inverse sine of -0.7. Get -44. So you can keep going and trying different numbers, but eventually you're going to realize, let's try like -1. Get -90. You're always going to get numbers between 90 and -90. Always. Okay? And there's a reason. I'm going to write that down in a minute, but I want to show you why. Okay? We all kind of have to agree on that we're going to get an answer between -90 and 90 because of what's happening right here. Right. So I would leave a little bit of space, like right after this, maybe 3 lines, and then we're going to come back to it, but I'm going to show you something first. Okay, So what I've put on the left there is just some different angles. And I'm going to take the sine of those angles. It's kind of like what I just did on the calculator, except now I'm going to write them down. All right. Actually, we just did that one. Does anyone remember what that one came out to? The sine of 30 as a decimal? 0.5. Yeah, that one was 0.5. The other ones, I don't know. We're just going to have to try them and see. So let's do sine of 65. Get about 0.91. Sine of 90. We just did that one. That one was 1. Okay, I'm going to hold off on 150 for a second. So, if you take the sine of 30, you get 0.5. What if you take the inverse sine of 0.5? It would give you back 30. Okay? When we took the sine of 65, we got 0.91. If you took the inverse sine of 0.91, it would give you back 65. All right? So inverse sine just brings you back to the number you started with. Now 0.91 is rounded. So maybe we'd get like 64.999 or something. Okay? But let's look at what happens here. If I take the sine of 150, watch what I get. 0.5. That's a problem. We didn't really have a problem up until that one. Why do you think that one's a problem? Based on what else is in that table? Yeah?
It's giving you the same answer as 30.
Yeah, get the same answer as 30. So now, before I showed you that one, when I said to everybody, okay, if you took the inverse sine of 0.5, what would you get? Everybody said 30. Well, now what would you get? You still think 30? Do you think you get 150? Well, problem is you've got two numbers here that gave you the same answer. When you do inverse sine of this, you can only get one of these back. You can't get both. Okay? So we have to decide which one is it going to be. Is it going to be 30 or is it going to be 150? They are both correct. So since we all want to come up with the same answer and not get different answers, we're going to agree on, okay, if you have more than one answer to pick from, pick the one between this number and this number. We're just going to agree that we're going to stick with numbers between, and I'll tell you what they are in a little bit. And those aren't the only two that would give me 0.5. I could type in sine of, let's do 390. There's another one that's 0.5. I mean, I could keep going. There's an infinite amount of answers that would come out to 0.5. But when you go back, there is only one correct answer. Right? So let me show you what the picture of sine looks like. The graph, it's a little bit different. We're going to study the graphs of sine, cosine, and that's all we really do. Sine and cosine next week. It's kind of like this wave pattern. Has anyone ever seen the graph of sine or cosine before? Yeah. If you study like sound, anything with like sound frequencies, or if you use an oscilloscope, you would see this kind of pattern. You do stuff with electricity, and you plug in like a special kind of meter into a wall outlet or a generator. You can see a pattern of the electricity and see that's how electricity should look. It should be like a nice sine wave. If it's more blocky, then it is nice and smooth. Sometimes you get that with a generator, and it affects how well motors and how efficiently things will run. That's why sometimes they say be careful if you use a generator, because the electricity isn't exactly the same as what you get in your house, unless it's a real expensive generator. So what I'm going to do is I'm just going to put a horizontal line at 0.5. Okay, that's 0, that's 1, that's 0.5. Everywhere that you see it cross is one of these numbers. Like this one right here, that's 30. This one right here, that's 150. What else did I do? Did I do 3? Yeah, I did 390. That one's right there. Okay. If I drew this horizontal line forever, okay, positive and negative, it's just going to keep crossing a bunch of places at 0.5, right? And that's the problem. We get tons of answers where it hits 0.5. We all have to agree on one, okay? And that's basically what we're going to do. So if I take, do I have? Let's go like this. Right there is negative 90. Right? And let me put another box over here. Okay, so what I'm doing is I'm just kind of blocking out what I don't want you to look at and just focus on what's not blocked. Let's make this gray. That's good. So look at the section that's just between the two gray blocks. If I move this horizontal line up and down, does it ever hit that blue curve now more than once in that section? No, it never does. And that's perfect. That's exactly what we need to happen. Right? It can only hit once if we're all going to agree on one answer. Now, if you just say, well, if you put those blocks anywhere, does that work? No, let's just slide it to the right. And now let's slide this a little bit to the right, if I can. I'll just go like this. That's exactly the same width that I just had. It's two marks wide. Does the horizontal line in that section only hit that blue curve once now? No. So if you see it, it can hit it. It could hit once, like right there. But in general, it could hit twice. So if we agreed to look at that section, we'd have a problem. Some of you may get one answer. Some of you may get the other answer. But as long as we all agree to look at, if I put it back the way it was, that section right there, we will always get one answer. This mark is at negative 90. That mark is at positive 90. So, if we all agree to look at the answer that's between negative 90 and 90, we will all get the same thing. If we don't agree to do that, then everybody could get something different. And if you're wondering, well, why negative 90 to 90? Why are stop signs red? I don't know. It's just something that somebody decided, okay, we're all going to agree to do the same thing. What do we want to do? Okay, let's go between negative 90 and 90. And then everyone's on the same page. If you're dealing in radians, that's between negative pi over 2 and pi over 2. Any question on that? Okay, so what that means is when you start doing this on the calculator or using this, actually just using this chart, we're going to look for the answer. You may find more than one answer on this chart. If you do, and you're dealing with sine, I want you to give me the one between negative 90 and 90. I don't care about the other ones. Okay, just the one between those two numbers. Okay, let's look at. So that's the graph of sine. Let me show you the graph of cosine. Just move this over. And you might think, well, isn't it exactly the same? If I show both at the same time, you'll see they're a little bit different. Get rid of those. Does anyone see what the difference is between sine and cosine? They're almost the same, it's just a little bit, yeah?
Well, the sine goes through the, what's that called? Origin?
Yep.
And the cosine does not.
Yeah,
It
it's,
goes up.
yep. So sine goes right through the origin. Sine is more like this. If I drew them both on the same thing. It's almost like if you just took a copy of the sine, like that, and slid it to the left or to the right, however you want to think about it, that's how you get the cosine. Just slide it a little bit left or right. So let's try the same thing. Let's try negative 90 to 90. Let's block everything else out. And let's see if we focus on that section, would we all get one answer? Okay, so just look at the section between the two blocks. Pretend like we put a horizontal line. Does that horizontal line only hit the curve once? What do you think? Yeah?
No.
No. That's a problem. So that means when we're dealing with cosine, we could have the same problem we had with sine. We could get different answers, and we don't want that. We all want to get the same answer, only the one answer. So what we're going to do with cosine is we're going to look at that section right there. No matter where I put that line, it's only going to hit one time. Does anyone have a guess where the left edge is? It's not negative 90 now. Where is it?
Zero.
Yeah, the left edge is at 0. And how about the right edge? Keeping in mind each mark on there is 90 degrees.
180.
It would be 180. So as long as we all agree to look at the answers between 0 and 180, we will all get the same answer. If we don't, then we could all get different answers. And it's not that those other answers are wrong. They are correct. But if the directions say, write one answer to the problem, then we got to agree what one answer are we all going to write. Okay? So when we're using this table, and we're dealing with a cosine problem, if you find more than one answer, stick with the one that's between 0 and 180. Okay? Or 0 to pi. Okay. Now inverse tangent, we don't really study the graph of tangent. Okay? The graph is totally different. Sine and cosine, they're nice, smooth waves. I'll show you the graph of tangent, but I'm not really going to talk about it. It definitely has a pattern to it. And you can probably imagine where you could have the same problem. If you put a horizontal line, it would hit the graph a bunch of times. So what we're basically going to do is we're going to block off what we don't want to look at, and we're just going to go between negative 90 and 90 again. Now, you might look at it quick and say that's the same as inverse sine. Not quite. What's a little bit different about my interval for inverse tangent compared to inverse sine? And this is going to be very clear when I point this out on the table. You're going to see why. Yeah.
Inverse sine is less than or equal to 90, and tangent is just less than.
Right. It's not equal, right? It's not equal. Watch what happens. Look at the tangent column. And look at the number 90 in the tangent column. When you look at 90 in the tangent column, if I scroll down a little bit, what do you see? Undefined, right? That's why it can't equal 90. Because if you equal 90, it's undefined. Why? We did it last week on the circle. That would be 1 divided by 0. Can't divide by 0 if we were writing out the coordinates and we did y over x. Right? That's why it's undefined. Okay, we did that. Yep, so that's everything there. Okay, so I'm going to summarize what I just showed you right here, but I'm going to kind of write it out in a sentence. Last week, I gave you an angle. You plugged it into a trig function and gave me the number. This week, it's reversed. I'll give you the number, you plug it into an inverse trig function, and tell me the angle. Okay, so anytime we're doing an inverse trig problem, the answer equals an angle. That's what you're solving for. You're solving for an angle. and I write that out right here. So inverse trig is the opposite of what we did last week. Okay, so last week, the question looked like that. What's the sine of 30 degrees? And you would tell me the answer, 0.5. This week, I'll tell you the 0.5. I want to know what angle would you take the sine of, and would give you an answer of 0.5. So that's where this chart is going to help us. Okay, so any question on the difference between kind of thing we did last week and now the kind of thing we're doing this week with inverse trig? So bottom line, what you want to remember is now you are solving for an angle. That's what you're giving me, an angle. Now, this table, obviously, I can't print out something that has every single inverse trig problem in the world, right? Because there's an infinite amount of problems. But where this table will help you is if the answer to your problem is a multiple of 30 or 45. Okay? So this chart summarizes everything we did last week without the calculator. I know we did some stuff with the calculator too, but this summarizes everything we did without the calculator. So I'm going to come right back to this, but you're going to have a problem like that. Find the inverse sine of 1, inverse sine of -1, inverse sine of a half. So how do you know when you should use this table? Well, it says that the answer to your problem is a multiple of 30 or 45. If you think about that, well, wait, how do I know the answer to my problem before I solve it? Well, you don't. You don't know if your answer is going to come out to a multiple of 30 or 45 directly. But what you want to look for that's going to give you a hint that your answer is going to be in this table, meaning your answer is a multiple of 30 or 45, look for numbers like that in the problem. 1/2, square root 3 over 2, square root 2 over 2, ones, zeros, negatives of everything I just said. Any number like this, you're going to find the answer in your table. If you get a number that doesn't look like that, okay, I'll come right back to it, but let me show you one that doesn't look like that. Here's one that doesn't look like that. Inverse sine of 0.65. You're not going to find the number 0.65 in this table. Why? Because this table is only answers that are multiples of 30 and 45. This is going to be some decimal. We don't know the answer without using a calculator. Right? So we'll do some with a calculator in a little bit, but let's practice with the table first. And after a while, some of these you'll probably remember, like inverse sine of a half is 30. Okay? Inverse sine of 1 is 90. Those are kind of some common ones that we see a lot. So you might, eventually as you do them, you just start to remember a few of them. Probably not all of them, because there's a lot. All right, so let's look at this one. Inverse sine of 1. Fine. So first thing I think of in my head, I'm like, okay, I'm doing inverse sine. I know that there could be more than one answer to the problem. So I think, okay, what did he say? We agree that the answer is going to be between this number and this number, if we have a choice of multiple answers. Someone remind me, what did we say when we deal with inverse sine? We're all going to agree to give an answer between negative 90 and 90, if we have a choice of more than one answer. Pick that one. Okay? All right, so let's look at our, I'm going to just go to the next page because I have the table on it. We're looking in the sine column, and we're looking for a 1. Once we find that, we're going to read off the angle that's in that row. So looking at the table, anyone think they can tell me what angle would you take the sine of and get 1 as the answer? This is basically what you're trying to solve. Tell me the question mark. What is the angle?
90.
90. Right there. Sine. All right, we know we're supposed to get 1. What angle does it? 90. Now, you also have a choice below it, and you should be able to read it on yours. It says negative 270. How come I wouldn't write the negative 270?
Because we agreed on doing between 90 and negative 90.
Yeah, we're going to do the 90 and negative 90. Okay. How did I get 270? What can you add or subtract to an angle and it's the same thing?
360.
Yeah, all you did was subtract 360. That's how I got all those negatives. That's all that those are. All right. So sine 1, read off the angle, 90 degrees. Or what if they wanted the answer in radians? What's 90 degrees in radians? Pi over 2. Now, if you're thinking, wait, I thought you said we're all going to agree on one answer. That is one answer. 90 degrees equals pi over 2 radians. That's the same answer. It's just different units. So there's your answer. Okay, let's look at another one. The inverse sine of negative 1. Okay, so what you're thinking of in your head is this. What angle would you have to take the sine of? And the answer would come out to negative 1. That's exactly the same question, just a different way to think about it. Okay. Anyone think they got that one? The inverse sine of negative 1. Yeah, Grace?
Negative 90.
Let's take a look. Sine. Go down to negative 1. Okay, I'm in this row. I see 2 answers. 270, negative 90. Which one are we going to go with? The one that's between negative 90 and 90. Yep, and that's correct. So negative 90. Or what if they wanted it in radians? Let's just do it one more time. Negative pi over 2. Okay, on the test and in the homework, it's going to be one or the other. Just read the directions. Okay, let's try inverse sine of 1/2. Inverse sine of 1/2. Let's look at our table. Now be a little careful with this one. Andrew, as I go down my sine column, what row is the first row that you see 1/2 in? What's the angle? Yep. You see it here. But now, keep looking. Does anybody see 1/2 again in the sine column in another row? The 150. So now you've got 4 answers to pick from. Out of the 4 numbers, 30, negative 330, 150, negative 210. Only one of them is between what we said. Yeah?
30.
Yep, it's going to be 30. Okay, that's the only one that's between negative 90 and 90. Okay, and if you're thinking, well, what if there's 2 answers between negative 90 and 90? There won't be. There never will be. Think of the picture and think of the horizontal line. It never hit more than once, as long as you stay between negative 90 and 90. So that is 30. Or if you wanted radians, that's pi over 6. try a couple more with inverse sine, and then we'll go to inverse cosine. Okay, so inverse sine of root 2 over 2. Okay, so first thing I do, I look at that and I say, yep, square root of 2, that's definitely something that's in my table. Okay, so you got to remember, first of all, what are the kind of numbers you're going to see in the table? 1/2, square roots of 2, square roots of 3, things like that. Okay, so let's go to our table. Max, what row do we see square root of 2 over 2 in the sine column?
45.
Yep. And do we really even need to keep looking to see if it happens anywhere else? No, because we already got an answer between negative 90 and 90 right there. We're done. Okay. The other answer is 135. It's not between negative 90 and 90. Okay, so there's our answer. 45 degrees or pi over 4 radians. Any question on that? Now, what if I asked you this? What's the sine of 45 degrees? Root 2 over 2. Exactly. Just the sine of 45 is root 2 over 2. The inverse sine of root 2 over 2 is 45. He's just going back and forth. Okay, and let's try one more. Inverse sine of negative root 3 over 2. So negative square root 3 over 2. And if you look carefully, you should find 4 answers. Yeah, Alex?
Negative 60.
Yep. Negative square root 3 over 2. I see it here. And I see it there. You gotta also make sure once we start doing other functions that you're looking at the right column. Okay, but those are both correct. Negative 60 is the one we want. Okay. Any questions on that? So it's the same idea with inverse cosine and tangent, so we won't do as many. Now, we're doing inverse cosine. Got to kind of switch gears a little bit. We're not negative 90 to 90 anymore. What are we supposed to be between now? Because if you look negative 90 to 90 on accident, you're going to run into a problem. Yeah?
Isn't it 0 to 1?
Right, now we're 0 to 180. Why? Because that's the section that if you look at it, we only get one answer. Okay? Okay. So inverse cosine of 0. I don't think they know what that one's going to come out to.
90.
Yep. Right there. Does 0 come up again in the cosine?
Yes.
Yes, which row?
270.
270. And some people look at that quickly and they're like, wait, there's 2 answers. There's 90 and there's negative 90. So there's 2 between negative 90 and 90. You're right, there are 2 between negative 90 and 90. But that's not what we're looking at. We're looking 0 to 180. And there's only 1. Okay, 90 degrees. Okay, let's try, take a second, try those 2, and then that'll finish up inverse cosine. And then we'll try 1 or 2 with inverse tangent. And that'll be it for using this table. Okay, so Brianna, were you able to find the inverse cosine of negative 1/2? Let's take a look. She said 120. Right, I agree that that's in the cosine, negative 1/2, and 120 is between 0 and 180. Yep, so perfect. All right, so we got 120. And Sebastian, how about inverse cosine of negative square root of 2 over 2?
135.
Let's check. So negative square root of 2 over 2, yep, it's in the cosine column. And 135 is between 0 and 180. Perfect. So any questions on how to use this table to look up answers for inverse cosine? Okay, let's do inverse tangent. Just 2 of those. So Megan, now we're kind of we're switching gears again. What are we supposed to be between when we're looking for an answer?
Negative 90 and 90.
Negative 90 to 90. Remember the difference. It will never equal 90. Okay. You really don't have to worry because just look at your table. If you try to equal 90, it's going to say undefined. So you can't do that. Okay, so I'm not going to give you one that's undefined. Okay, so the first one is inverse tangent of square root of 3. All right, so Courtney, if we look in the tangent column, where do we see that one?
60 degrees.
Yep. If you keep looking, you'll see it again, but it doesn't matter. And if you say, well, is it always the first one you see? Like you just go with the first answer you see? No. You always got to go with the one that's between whatever it says. Okay, I can't tell you if it's going to be the first answer you come across in the table or the second one. Depends. Okay, and how about last one? Inverse tangent of negative root 3 over 3. Yeah. Negative 60. So I think you were looking in the column that's 1 to the right. You were in the cotangent column.
So negative 30.
Yeah, I think negative 30. So it's easy to look at the wrong column because there's a lot of stuff. The negative 30. Okay, so questions on that? Okay, so pretty easy to use the table. So now, if you can't find the answer in the table, that means it's not a multiple of 30 or 45. Okay, we're going to use the calculator. Let's start 0.65. Is 0.65 a number that's in our table? No, it doesn't fit the pattern of root 3s, root 2s, 1s, 0s, 1/2s. It's not in the table. So, I'm going to show you how to type this in on my calculator. Your calculator might be a little different. So once I'm at my main screen on my calculator, to get to any function that has the -1, you're going to press second. That's it. You press second, and then sine. And now type in 0.65. Now, what did I say earlier? When you do inverse trig, you're solving for the, like, what is that number? It's, or and, what? It's an angle, right? Look at my calculator. What's going to be the unit on my answer if I hit enter like this? Which is fine. Yeah? Well, the answer might have a decimal in it, but what's going to be like the units on it? Degrees. Yep. Degrees. My calculator is in degrees. Okay, so it's going to give me an answer in degrees. Is that right or wrong? I don't know. It depends on what the directions say. Okay. If there are no directions, well, there will be on the test. But if there aren't, you can pick degrees or radians. So there's the answer in degrees. 40.54. If you wanted to do it in radians, there's no difference at all with how you type it in. Type in the exact same problem. Let's go second. There we go. Just change the mode. So it's about 0.71 radians. Okay, you do not have to write both, I'm just showing you how to do both. Okay, say this was multiple choice, and they gave you these as answers. 0.65, 40.54, 0.71. Which answer there is correct?
Would be the one in degrees.
There are no choices in degrees here. It would be C. Yes. 0.71. Okay. About now, which answer is correct? B. Okay. I will do that on the test. And some people will get every problem wrong in that section because of that. It always happens. So you've got to look at the answer and see, do the answer choices have degree symbols on them or no degree symbols? That's how you know if your calculator should be in radians or degrees. Okay. Any questions on that? Okay. Let's try this one. Inverse cosine of negative 0.24. Justin, can you tell me if I want to do this in degrees? First, I'm going to just change it. But after I do that, can you tell me what I press to type it in?
I'm gonna do 1 divided by cosine. Or no, just negative cosine.
So so can you tell me what to press? It's going to be the same way we just did inverse sine, except I'm going to press not the same button, but one next to it.
Pressure for here, but it's just, I don't know.
Second, and then cosine,
Second, cosine.
and then here.
Yeah, and then this thing right here, that's your argument. The argument is just the thing that you're typing in. That's all. I think I used that word earlier in the notes. So inverse cosine of negative 0.24 is 103.87 degrees. Okay, and let's try one with inverse tangent. Matt, can you tell me, assuming they want the answer in degrees, I'm already in degrees, so that's good, what I would press to do that one?
No, I did second tangent.
Yep, second tangent,
34.3.
34.3. Okay. So remember, that 34.3, just a number. This is not radians, this is not degrees. It's just like the length when we did a coordinate. Part of a coordinate, that's all it is. That is in degrees, 88.33. Okay, so typing it in on the calculator, pretty easy. Second, press the trig function you need. Okay. Last thing we're going to look at is how do you type in one of these? So I asked this earlier and I said, how did we do it last week when it was a regular trig function? I think it was Matt. Someone said you flip it. Well, you're kind of going to flip something here too. This is what we did last week. If you wanted to know the secant, you took and flipped the entire trig function. That's last week. You found the cosine, and you put the whole thing, function and argument, in the bottom of a fraction. Let's see what happens here. Okay. Why is this a problem to type in? What's wrong? Yeah?
There's no secant on the calculator.
Right, there's no secant button. So if I give you a problem that says find the inverse secant of 1.45, you don't have a button. Okay? And you might think, well, flip. Yes, the right thing, okay? It's not quite flipping like that, but you'll see what it is in a second. All right, so it's a little tricky to figure out, but my goal when I'm done is to get a different formula for y, but the formula somehow involves inverse sine, inverse cosine, or inverse tangent. I want this formula to involve a button that I have on the calculator, not a button that I don't have. Okay, so we're gonna get a little bit different formula. All right, first thing I need to do is rewrite this by getting rid of inverse secant. What trig function do you think would cancel out inverse secant? Like we saw that cosine cancels out inverse cosine, or they're opposites. Sine and inverse sine, opposites. Inverse secant and regular secant. So, if I take the regular secant of everything on the left and the regular secant of everything on the right, it's just like taking the square root of each side, right? Except this is not square root, this is secant. Those cancel out. And now I have x equals secant y. So remember, when I'm done, I want to get y by itself again, but a little bit different formula. Well now, look at this, and look at that. We have a way that we can rewrite secant. Regular secant, that's not inverse secant anymore. It's regular secant. How can we rewrite secant in terms of another trig function that we have a button for? Adam, you see how we could rewrite secant from last week? Do you remember what secant is? So like if we wanted to type secant into the calculator, we had to type in something, because we don't have a button for secant. 1 divided by what?
Secant.
Not secant, but cosine. Secant is 1 divided by cosine. So now rewrite that the way we learned last week. Okay. Might need one more line here. This is 1 divided by oops, do it like this. Secant, how do we want to do it? We want to take and flip it. So let's go like this. So I flipped it. 1. Yeah. All right. Actually, no, that's not. We want to flip it. Oh yeah. Let's flip each side. So instead of flipping one side, let's flip both sides. Just like this. That's fine to do as long as you flip both sides. Okay, so all I did was take what's on the left, I flipped it. I took what's on the right, and I flipped it. And now this is what we learned last week. If you take a trig function and flip it, like the secant, you get the cosine. Right? So this is really just that. If you take the secant and you flip it, that's the cosine. If you take the cosine and flip it, you get the secant. Okay? So if you flip cosine, you get secant. If you flip secant, you get cosine. Now, our last step is to put cosine back on the other side, and we're going to have y by itself. Right now, this is what's preventing y from being alone. So what trig function would get rid of cosine on the right? You don't say divide by cosine. You can't divide by a word. You can only get rid of a function with another function that's the opposite of it. Yeah?
Inverse cosine.
Inverse cosine. And now watch what happens. Inverse cosine of what's on the left, and you have to do it on the right. Inverse cosine, regular cosine. It's like square, square root. They cancel out. Look what's on the right now. Y. It's exactly what we started with on the right. But look what's on the left. Inverse cosine of 1 over x. That's something we have a button for on the calculator. So we have a different formula for y, and now the formula is something that we have a button for. So let's look at what happened. Something flipped, but all that flipped was what was right here. So if you want to do inverse secant, you're going to use inverse cosine, but you have to flip the number that's inside the parentheses. That's a little different than flipping the whole thing. All you're flipping is just the number that's right there. Okay, so let's try that on this one. All right, so I don't have a button for inverse secant. So Emily, what function are we going to use instead of inverse secant that we do have a button for?
Cosine.
Which one?
Cosine. Or like the one, or the inverse cosine.
Yes, the inverse cosine. So you can do this problem with inverse cosine, but what do you have to do with the 1.45? Oh, Jason?
You do 1 divided by 1.45.
Yep. That's the only way to type in a problem like that. Okay. Find the trig function you have a button for, but flip what's inside. Okay, so it's flipping, but it's not quite flipping everything. You're just flipping what's inside. 1.45. And we get 46 point, if we round it, it's 46.40. Okay, let's try this one. Brandon, do I have an inverse cosecant button on the calculator?
No.
No. So I've got to find the button that I do have that goes with inverse cosecant. So think back to last week. What trig function do we use with cosecant? Yep.
Sine will use inverse.
Yep, you're going to have to use the inverse sine button. Because remember, sine and cosecant go together. But you can't type in 2.6. What do you have to type in?
1 over.
1 over. Yep, you have to flip it. Not the whole thing. Just what's inside parentheses. Okay, so inverse sine, 1 over 2.6. And you get about 22.62. Okay, and last one. Inverse cotangent. Stephen, do I have an inverse cotangent button?
No.
No. So what trig function am I going to use instead?
Sine.
So we use sine when we're dealing with a cosecant problem. What trig function would we use when we're dealing with a cotangent problem?
Would be cosine or no?
No.
Tangent.
Tangent, right? Inverse tangent. You use inverse cosine with a secant. You use inverse sine with a cosecant. You use inverse tangent when you have a cotangent problem. Okay, so you got to remember those pairs. But Courtney, what would I type in since I got to do something to what's inside?
So you do 1 over 0.35.
Yes. You only need to flip it when you're doing one that you don't have a button for. If you have a button, just type it in the way it is. Okay? Like the first three. Okay, so second inverse tangent, 1 divided by 0.35. So it's about 70.71. Okay, I did all of those in degrees. If they wanted radians, type it in the same way. Change your mode first. Okay.
How do you tell us degrees if it, like 0.35 doesn't have degrees in it?
The only way I can tell is because my calculator is in degrees.
Yeah, so you just do it in degrees.
If the problem said write in degrees. Yep. Remember, this right here is just a number. It's not an angle. This is neither radians or degrees. The answer that you get is radians or degrees. Okay? Think of this as it's like an x or a y value from a coordinate. That's all it is. It's part of a coordinate. It's not radians or degrees, but that is. Okay, any other questions on the calculator? I think the last part, that's the trickiest part. Okay, so that's the homework for tonight on 187. 13 to 17, 19, 20, 22 to 31, and 33. So tomorrow we'll finish up section 3.1. There's not really much left. And we'll start 4.1, which is the last section for the week. And we'll split that into 2 days. Okay, so as I confirmed, the pep rally, yeah, it's at I think it's like 120 or something. So we'll do a review day on Thursday before the test, okay, just like last week.